So back to our dynamic array itself, right? Our dynamically resized array. And this is going to be in contrast to our traditional arrays, which are statically sized. Dynamic arrays are designed to automatically resize when you add data. So you're never going to need that trailing information at the end where, like we saw before, I've got an array of 11 slots, but only the first 5 are used. Okay? But the question becomes, are these things really dynamic? Do these arrays actually expand on demand? And the answer is no. Dynamic arrays behind the scenes are just a static array. Right? This is an abstraction. This is what I was talking about when I said that one of the aspects of object-oriented programming is abstraction, where you want to capture the behaviors that you need and then hand off all of the rest of the detail to a lower level system. Right? Our dynamic array provides a really fancy interface and some new behaviors like append, but otherwise hides how you're going about storing the information. So the dynamic array is coded on top of a static array, and it's going to handle things like creation, copying, and destroying an old array when we run out of space. It's going to handle the maintenance of a count variable. It's going to handle the maintenance of that empty slots at the end of the array. So really, truly, behind the scenes, when you have a dynamic array, when you have a Python list that has A, B, C, and D in it, it looks like this. But in reality, A, B, C, D, and then you have a bunch of nuns behind it, right? You might only have 2. And then it'll resize when you run out, when you try to add your 7th element, right? We append, and then we append, and then we append one more time, and we can't. So what does Python use? I've already told you a little bit, right? You can force a static array. You can force a traditional array. Remember, it's all built on C, so everything's there. But the built-in type is dynamic. Okay, the built-in sequence type is the technical term, right? Because notice how these are sequential, right? They are in sequence, physically in memory. The built-in type is dynamic. So briefly, let's talk about Python sequence types, right? The default setting is a Python list. A list is a dynamic array. It's got some additional methods to it. You got a way to add objects to the end of the list. You can get the length, right? Now, you're allowed to use this for a static array as well. But as we'll see in a few minutes, this is really a method of a class that is implemented behind the scenes. So there's all sorts of other methods, and you can look that up, right? And I'm sure you have experience with some of this. But Python doesn't just have the list, right? You have other sequence types that you can use and whose interface is largely similar. And the difference is they're immutable. You have the tuple and you have the string, str. Okay? These have access to many, many, many accessor methods, as well as indexing and slicing, right? So if you've got a string called s and you want to get the 3rd character, you can just do 2, right? But what they don't have are mutator methods. So you can't say s.append. That's not going to work, right? Because they're immutable. So you can't mutate. You can't set something. But indexing and slicing works for all 3 of these data types. Okay? Largely functionally equivalent. And your lab 1 probably gives you some experience with, enough experience with tuples that you've now realized, hey, yeah, tuples and lists work very similar. Right? So all 3 of these calls are valid, right? A traditional, hey, give me the value at the index. Hey, give me the range of index. Hey, give me everything from the beginning to this index. But what values are going to get out for this, right? I will tell you. Let's take a brief sidetrack. Right, we had some code examples on the previous slide, right? Index list of 1 is easy to understand. Get me the element at index 1. But I find, even for me when I was learning to do this, that something like this, it's a little trickier, right? Give me everything between 2 and 5. Does this mean give me everything in slots 2 through slots 5, so slots 2, 3, 4, and 5? Or does this mean get me the elements in slots 2 up to, but not including 5, so slots 2 through 4, 2, 3, and 4? Or does this mean get me the elements between slots 2 and 5? So get me 3 and 4. So I came up with a handy way to think about this, and students find it pretty helpful. So let's go over this real quick. Hopefully it will help you out if you don't know what is returned by 2, 5. So let's consider this array. Okay. Take the 2 indices and draw lines in front of both of them. So draw a line in front of the 2 and draw a line in front of the 5. That is how you slice. That is how you get a subsequence. Okay. Remember the 0 to 3? I'm sorry, the nothing to 3. There was also the str1 blank to 3, right? That's essentially the start to index 3. So we'd put it before the start and we'd put 1 before index 3. Same concept. And if you think about it, 5 minus 2 is 3. We got 3 elements out of this, so it makes sense. Okay? I have found that this trick is true for any language where sequences can be based on indexes. So Java has this method called substring, which does this for strings, and it works this way. The trick is some languages don't have it this way. C#, and I've coded in C# for years, okay? C#'s parameters are index and then length. So this says start at index 2 and give me 1, 2, 3, 4, 5 positions. So obviously that's a different thing. But this is just a little trick for you. Now back to dynamic arrays. Now back to dynamic array behavior, right? We need to talk about different ways that we would handle behaviors, things that we're going to want to do, okay? And these are just hypothetical. We're going to take a look at some code then, and the method declarations may not perfectly match what we're going over here because, again, there's not a fully formalized interface for what a dynamic array, how you interact with the dynamic array. More of there's a formalized set of expectations, right? So if we want to create a new dynamic array, right, we're going to need to declare something that creates something. So if we're coding our class, that means we're going to need an initializer. Notice that it's not going to take any parameters because when you call the initializer, it's the default setting is nothing is in the array. Yeah, we could create an initializer with some optional parameters if we wanted to and iterate through the things if we wanted to. That is an option. But we are going to just go with the default setting. We're also going to need to get an element, right? Hey, how do I get the thing at index 5? Well, we can declare dunder get element, right? Remember, this is the magic method. This is how we do slicing in Python. Declaring that method will, sorry, not slicing, indexing. Declaring that method will define how indexing works and will allow you to index. Similarly, we need to get the length, right? So we declare dunder len. And when we do that, that will define how behavior works when you put an object of this type inside of the len function. We're also going to need to return an element and remove it from the underlying array. So we'll define a remove method that gives an index. We're going to need to be able to insert an element. So this one's going to be a little more complicated, right? We're going to need an index where we want to insert, as well as an object to insert, right? So we're going to put it in between, like we saw before. And we're going to need to append an element, add something to the very end, right? Insert in the best case. And we could come up with more methods, but these are kind of broad methods that make sense, right? This is what we were talking about. This is codifying the values that we were talking about for the static array, right? This is your read and write. This is your remove. This is your insert. And this is also your insert only at the end. So here's the question. For these two bolded behaviors, what do we need to account for? What could happen with these two bolded behaviors? And the answer is, we could run into a case where we don't have enough space and we need to resize our array. We could have 6 slots and they're all full and we're trying to append. And what do we do?